Here we are looking at example 5 from our 2.4 number 1 set of notes. We're asked to write the equation of the line that is graphed right here. Well, we see that we have this line with 2 points that are very identifiable. This first point happens to be -1, -2. And this other point looks like it comes out to be 1, 2, 3, 4, 5. So anytime that you have 2 points like this, you can go ahead and find the slope of those 2 points. So we know that slope is y2 minus y1 over x2 minus x1. Let's just go ahead and say that this guy is x1, y1, and this will be our x2, y2. Again, it doesn't really matter as long as all of your math and algebra is actually good. You should end up with the same exact slope. So just throwing those values in, we end up with y2, here he is, 5, minus your y1, coming out to be -2, all over your x2, here he is, 4, minus our x1 being -1. Anytime you are subtracting by that negative, you are really adding him. So we have 5 plus 2, that comes out to be 7, over, again, subtracting by a negative, we're really adding there. So it looks like we end up with a 5 on the bottom. So our slope for these 2 points comes out to be 7/5. Now, that's all great. We found our slope, but now we actually still have to write the equation of that line. Well, if you recall back from point slope, anytime that you have a point and a slope, you can go ahead and use point slope. We are actually lucking out. We have our points, we in fact have 2 of them that we can kind of choose from, and our slope. And then as a result, we can use our point slope. Y minus y1 is equal to m times x minus x1. So it doesn't really matter which point we choose, because again, both of these points are satisfied for this line. Let's go ahead and maybe go with this 4, 5. So we end up then with y. The first guy is arbitrary. We're going to leave him as just a regular y. Minus our y1. Well, in this case, it's 5. Equals our slope, m, which is 7/5, times our arbitrary x minus our x1. Well, again, we were choosing this point 4, 5, so our x value that we're going to go ahead and throw in there is 4. Simplifying things up, we end up with y minus 5 is equal to 7/5 times x minus 4. So kind of just getting rid of some of those parentheses. Going ahead now and distributing in this 7/5, we end up with y minus 5 is equal to 7/5 x minus 28 over 5. Now we want to put things into y is equal to mx plus b, so we're going to go ahead and try and solve for y here by adding 5 to both sides. Here they are gone on the left side, leaving us with just y is equal to 7/5 x. Now when we're trying to combine this -28 over 5 plus 5, well, 5 right here is the same thing as saying 25 over 5. So ultimately we're really adding 25 over 5 now. So -28/5 plus 25/5 comes out to be -3/5. And again, this was just a little bit of foo to get that value. So as a result, here is our equation of our line that passes through these 2 specific points. Now, what I'd really like to do is go ahead and show you what would happen if we plugged in this other point, -1, -2, into our point slope. Well, again, so we'll just kind of leave ourselves some space. We have y, that first value is y just by himself, he's that arbitrary y, minus our y1. Well, our y1 again was -2. So we're just throwing that value in, equals our slope, 7/5, times x minus our x1. Here he is, -1. Simplifying things up, we're trying to take the opposite of -2. Well, really, we are adding that 2, so we end up with y plus 2 on the left side is equal to 7/5 times, really we're taking the opposite of -1, so we are really adding that 1, giving us x plus 1. And now going ahead and distributing in this value, we end up with y plus 2 is equal to 7/5 x plus 7/5. Again, we're trying to get things into that y is equal to mx plus b. That's why we distributed. And now trying to solve for just y and get it equals to mx plus b. So we're going to go ahead and subtract 2 from both sides. Looks like we end up with just y on the left side is equal to 7/5 x. In order to be able to combine these, we have to have the same exact bottoms. Well, -2 is the same thing as saying -2 over 1. In order to actually subtract this, we have to have the exact same bottoms again. So we're going to do a little bit of foo. We're going to multiply this by, we need the bottom to be 5, so we also multiply the top to be 5. And then we'd be able to subtract the 2. So we end up then with -2 times 5, well that's -10 over 5. And -2 is the exact same thing as saying -10/5. But now that they have the same bottoms, we can go ahead and combine our tops. So 7 minus 10 gives us -3/5. Lo and behold, these do in fact match. So again, that was really just to illustrate that when you're using that point slope at this part, it really doesn't matter which point you choose for your x1, y1. Okay? You should end up, as long as all of your algebra is good, you should end up with the exact same equation of the line. And that actually makes sense because, again, both of these points are satisfied for that equation of that line. So, again, that is example 5 from our 2.4 number 1 set of notes.